Good morning, everyone. Welcome to another session of our webinar series. Today, we will discuss analysis and design of flow system in ETABS. So today's objectives are introducing you to the modeling tools available within the program, the analysis and design features, and recommended usage of the program. So this will be focused on the floor slab system. In the previous webinar on SAFE, we discussed the foundation system that is already available in our YouTube channel. So just to briefly introduce SAFE for new users, the SAFE is a special purpose analysis, design, and detailing program built specifically for floor and foundation system. And the software seamlessly integrates model creation, analysis, design, and detailing into a single GUI. So it utilizes the same Sapphire analysis engine that is used in other CSI products. Someone is new to the SAFE program, if they're already used to ETABS, it will be very close to ETABS. So interface, usage, everything remains pretty much close to the ETABS program. Or even a SAP user can also adapt to this new software. So the SAFE follows the object-based modeling approach. So the objects are the frame objects, shell objects, tendon objects in case of PT slabs, and joint objects, right? So these objects represent the physical structural members like a beam, brace, column, floor slab, wall, etc. So we will have them defined as a frame, shell for most of these members, and then use them in the modeling. So the workflow. So the workflow is you begin the model by creating completely within the SAFE environment, or you can import model from Revit for BIM compatibility. You have this a plugin that sits with the BIM program, the Revit program, and you can transfer the model to the SAFE. That is possible, which is also possible with ETABS as well. So the same input, import option is available here in the SAFE program. Other than that, you also have DXF to import geometries easily. I'll try to show a few examples. And then the rest of the thing within the SAFE program will start from the definitions. So definitions of materials, properties for various members. So using that definition, you will draw the objects, the analytical model, and then select the members and assign them with loads or change properties. Then loads applied to these members, support conditions, etc. All of this will be completed till this stage. So define load cases is kind of automated for most cases, especially the linear static cases, since we are in the SAFE program. So if you are importing a story from ETABS, then it could be a foundation system or for floor slab system. can be easily imported. So all the load patterns through which loads will be transferred, and for each load pattern, program automatically generates the load cases. So if you want to create a special cases by combining more than one load pattern, then you can do that as well. And then you can perform the analysis and you'll get the results for these cases. You can review those results and then you can perform the design of the members. So SAFE supports concrete slab design, PT slab, as well as composite beam design within the SAFE program. And you can also perform a detailing, a feature available within the program, and you can also generate DXF or DWG files directly from here for further manipulation of that output. We have various output graphically and tabular and export options for all of those are also available. So this is the workflow which we are going to follow. And specifically on the import and export capabilities, we discuss about the BIM integration through the Revit, last one. The rest of the things we will explore in an example shortly. So the types of analysis typically used are linear static analysis, and the other one is nonlinear static. So nonlinear static is used, for example, for foundation uplift. For floor slabs, you'll be checking cracked deflections, short-term, long-term deflections. So other types of analysis also possible within the program are listed below. So the slab design involves definition of load combinations, which is automated. As you define the load pattern, program recognizes the type and applies the load factor required, similar to ETABS, and can generate design load combinations based on the code set under the design preferences. Then flexural calculations, and then serviceability for PT, checking the stresses, and then punching shear check. Within the slab flexural design method, this program performs by default the FEM-based design, which is always available to you. But our recommended method would be the strip-based method. So bidirectional strips has to be drawn, and then so the moment integration will be done for these strips. They will be used as the forces for the design, and the design procedure will utilize the requirements based on the code selected for the design. So FEM based is available, which is given in situations where the strips cannot be drawn because of the slab geometry, irregular or complex. Then you can utilize the FEM method. So this is independent of the design strips. So you get two outputs whenever you draw the design strips for designing the slabs. You'll also get the FEM based output. A strip based method should be used if you want to perform the detailing action. For FEM based, detailing will not be performed. And there is an option to input user-defined slab rebars within the section, within the members. That is to utilize in the nonlinear cracking analysis. So design strips typically grouped under layer A and layer B that represents on each face of the slab. You'll have the orthogonal direction of bars running across. So one layer you can group under A, so for example, X directions, all under A, and Y directions, all under layer B. So you can also tell which layer is outer. So while designing, it will pick up the effective depth according to that position of the layers. And then the geometry, it follows a polyline. You can draw. Um, you can draw edge to edge of a slab, or you can also break between supports where the columns are. Then these lines will be used to have the information about its width, how much width on the left, how much width on the right. There are a few automated options available, and manual option is also available. We will explore it in the example. Right. So it need not be strictly orthogonal. It can be orthogonal because of the geometry of the slab. It can be radial or other non-orthogonal directions. And these orthogonal or slightly not non-orthogonal strips will be overlapped. That is totally fine. So within the strip, you have the column strips and middle strips. So in the design, it doesn't have any effect. You can use any of this, but typically the usage will be drawing the column strips over the columns, and between two column rows, you'll get space for drawing the middle strips. We'll be using middle strips for them. So the column strips are utilized in the PT slab. For RC slabs, you can use the combination of columns and middle strips for convenience. Specifically on the punching shear check, so it's an empirical code-based check for concentrated loads. So program tries to identify the columns that it is interior, edge, or corner. It has the capability of using an algorithm to find the boundary criteria and openings to exclude those portions of the punching perimeter. Right. So this is explained in a key terminologies um, manual. For more details, you can refer to that. But basically, this is what it does. It is trying to identify the punching perimeter possible for that location. And you have the option to override as needed. You can also specify user-specified punching perimeter, depth. Everything is possible through the overrides. In case you find the detection by the program is not acceptable. That is totally possible. And the punching is reported as a demand capacity ratio. So any ratio less than or equal to 1 is safe, greater than 1 is not safe. All right. Let us jump to the safe program. And we'll do a flat slab example here. And along with that, I would cover the features that we have discussed so far. So I will start a new model. So you'll get model initialization. You can start completely from scratch. So I'm using third option, setting the display node symmetric SI. You can set up the codes. And then we can start from here. Before I pick up the example, I will show you some of the options that are available right from here. So we have the grid definitions. Remember that this is a one-story model or the datum level where we are going to model the slab, and then that would be the focus for the analysis and design. We can model the vertical objects like walls and columns above or below that are going to only provide the support. The design will be focused only on the datum level, whatever you model. The same applies for foundation system. before I come here, I will use the default settings and enter into the blank option without defining any grid system. This is to show you how to import any complex grid system you have generated in a CAD program and import it. Then go to the file, import TXF file architectural grids. We have a grid system defined as a TXF file, and the CAD program units and the layer in which the grid lines are drawn. Save this. You can see the grid system has been imported, and these are editable under the edit grid systems. And these grids are imported under the general grids. You can modify this if you want, but it's completely editable. Modify this further. And the rest of the things follow. So this is importing the grid, and you can start working with the modeling options. Close this. I will use another option. Again, through the CAD, new model, blank. This time I'm going to import an architectural floor plan and utilize it to create my model easily. Go to the file, import TXF DWG file, architecture plan. Select the DWG file, a flat slab model. Any modification needed, you can specify here. And now what you see is just a layer of that drawing in the CAD program. Now this information you can find under the Model Explorer display tab. If I expand this plan view, you can see architectural layers, various layers are there used to create these. And for example, all the slab area objects have been created under this slab name. To utilize this, I can use these layers listed here, or I can directly use draw floor wall object, and I can use quick draw option. And draw object using, there is a control which allows you to change into architectural layer. Select this, and if I reach, it will highlight. Let's say if I select the larger slab area, it will quickly create. So individually, if you have different properties and you want to add them at different location, you can add them like this locally, right? I will show you another option. So under this Model Explorer, if I go to this slab, right click, and you can see add area object and quickly easily. And using the columns layer, can add column object. Right. Let me show this in a 3D view. Later, you can individually control the layers from here, show or hide, but there is another option under the options, architectural plan options, deselect all to remove them from the view. Now we are with the model itself. Now you can modify this further with specified properties individually. So although I have shown it to you with a simple model, imagine that it is a very complex and you want to create quickly, then this is the easiest way to do that. Right. Now let's create another way, which is the standard way of using this. Create a new model completely from scratch again. And we will create the grid only option and create all the objects similar to ETABS directly inside this save program. So 8 meters span, 3 spans in X and Y directions. Now you can see the model datum is 3 meter, and then above and below have 3 meters. But our focus is only on the model datum. There is one more import where you can also completely create the floor plan, including the strip data, tendon, everything. But that is available through floor plan, which will be more complex. But these two are much easier to use, convenient to quick start your work in the modeling. All right. So the definitions, material property, section properties, slab section 200 will add a drop. So the property type will be drop. So the modeling type is important for the analysis. For the design, this property data is utilized. Otherwise, the behavior will be based on this modeling type itself. Next, drawing. Quickly draw the columns. So here you have story above, story below. So this is a datum level. I'm sorry. Quick draw columns. So we want only the columns, and it should be at the below of this model datum. So above, we can have the property, but we can control it with the dimension. Below 3000 default height, using the same. Above is 0, that means no columns will be modeled. In concrete column, can do this. And we can draw the slab. So our recommendation is to draw the floor slab fully as much as possible as a single entity, and any change in thickness can be modeled by overlapping the existing slab at locally, like the drops which we are going to draw. And use the same drop 3000, 3000. So this option will create objects quickly with the specified value. I will use the another option, draw, quick draw around points, and this will help me with trimming at the slab edges. You can see in the previous case, you will have to modify it, but here that's all. The loads added to these members will be additive, important to note. So you need to select only the floor slab and apply any additional loads to this, dead loads and live loads as usual. That's all. Now this is ready to run the analysis. Now to this, we'll be adding the design strips. So design strips requires a bit of an effort, but there are tools that are going to help you. One is under the draw. You can draw the design strips directly by picking up draw design strips, like I can do here. So design strips, you have to click start and end. So I'm going to click here and here, but I can also click between the support points, which will help me in reporting values within those broken segments of the strip. Right. Now, if I stand here and look at the second point click, then I will have my left and right, and those dimensions are given here. So you can provide, let's say 2000. Right side, I'll keep 0. And I can draw this. So I used the default settings, which is layer A. This is for X direction, so I kept it in layer A. And then I kept this as column strip because I'm going to draw these column strips first. Next, I'm going for the interior one. So both left and right, I have 2 meters and 2 meters, and that makes the strip width as 4 meters. Right. So this is one way of modeling this, and you can also use the replicate to model if it is possible to do the replication. And replicate, you can select and replicate the object. Another option is, we remove this, I will show you, is to draw support lines. Support lines will help you in generating design strips automatically with the automated feature. You select this. So for layer A, all of these will be grouped under layer A or layer B. All right, I have drawn these four. And then now we have the option to draw the design strips in two ways. One is add design strips using grids. If grids are properly defined, and then we can utilize this, and program can quickly generate this. Say, for example, for the X direction, we'll group all of these under layer A, and you can tell a fixed width how much you want to have, and also include middle strips if you want. If I leave it to auto, and if I press apply, you can see grid lines are created. Small adjustments should be made. Let us look at the width of these strips generated. Right. Those are the adjustments needed here. Here, you can see there is no physical slab here, but strip width is exceeding on the left side, so we'll have to modify this. So modify is possible by selecting strip, and under the edit, you have edit strip width, or can directly right click, selecting support line. I'm sorry, so support line has to be hidden. We'll come to the support line. Now if I select this, will select strip, edit, now edit width. Currently it has used the auto. You can modify the strip width, putting this to 0. So this kind of adjustments we'll have to make. But imagine it's a big complex model, cannot draw all of this manually. So you can utilize any of these features. So the other feature was this, utilizing the support line. I will also demonstrate that. Let me remove this. Design strips generated using grid lines. I will now use the support lines. Now there are 4 support lines. I'll select them, edit, add support line. Sorry, support lines are drawn. This is for the design strip. Add design strip using selected support line. Similarly, whenever you generate, you can include the middle strip or this fixed width or auto. So with auto, you can see it can also generate easily, right? So this orthogonal panel for the layer A and layer B, it's a rectangular panel. So perfectly orthogonal strips you're going to generate. Imagine it is a circular shape of floor plan, or it is having a radial distribution of the strips. Then you can draw these and then create them easily rather drawing this manually. All right. Let me create one more quickly from the template, and we'll continue our discussion in rest of the features. Directly from there, I'm going to pick up a flat slab that will have the complete information. Let's put 500 column size and drop 3 meter by 3 meter, 350. It's okay. And you also include model column intersection as stiff slab. So the column and the slab or the draw, that junction can be modeled using a stiff. Program allows you to add the PT, but this is not included in today's discussion. We will do an RC slab design, dead load and live loads. Let's change that model. So with this, generate So we'll get from the template all of those modeling requirements, including the design steps, readily available. If the floor system is fairly um, rectangular and symmetric, then you can utilize this, and then you can modify this later by doing all the editing options available for alignments and move commands will help you in doing those things. So various other editing options for the shells also available: to divide, expand, shrink, all these options can utilize to complete the required modeling. Now let us focus on this. Let me save this to file type is FTB. All right. Under the set display options, we have the option to extrude frames and shells. That will show you the extruded view. All right. So the dead load and live load patterns are by default generated, and we are replacing only these two. In case you're importing a story from etabs, it will carry all the information. So in etabs, for the export, we have three options. The first option is to only transfer the story, geometry, and object loads applied on those area objects and line objects that will be exported into the safe program. Second option in that would be exporting the previously discussed plus loads from above, which is typically used for foundation system. But in case of transfer girder level or transfer slab level, then the loads from above acting on this floor also needed, then you'll use the second option for the export. Third option is only utilized when you are dealing with the temperature loads. All right. And all the loads are applied through the load patterns. So you'll see this list populated based on the load patterns available in the etabs and exported here. And load cases for each of them will be automatically included. So the program handles this load transfer in two ways. One is the load pattern that exists here and all imported in another set. Right? If you see dead load is available here, right? When there is a dead imported from etabs, then it will be suffixed with dead underscore above. So the dead underscore above load pattern will carry the load from etabs. So anything that is modeled here, assigned any loads through this dead load pattern here within the safe will be available here. And the load case will have both of them together in one case. So the entire process is completely automated. So you can simply use the features and go ahead and review the results for the analysis directly. But I wanted to give you those inputs. So dead and live load cases. Now combinations, you can define your own combinations or add default combinations based on the code selected. Program can generate. If you don't have any load combinations, when you're hitting the design button, program will generate those combinations required for the design. All right. Now let us run the analysis and design. Before that, let us have a quick right-click information about the design strip. Just having a width of 4 meters and the design is performed using a rebar material 415. Note the rebar material comes through the design strip and the slab carries the concrete material. So you can change the rebar directly from here. That will affect one design strip. If you want to modify multiple of similar type, you can select this and you can go to the design slab, design, and you have the overrides for the strips. Right here, I can simply select or add a new material and update this strip or selected strips directly from here. The other thing it also carries is the cover information for the slab. You can specify it directly here, or it can pick up the cover specified under the design preferences. Okay. So these are the two things wanted to let us go to the analyze and run analysis and design. Right. So the program has the default setting for the meshing from the analyze automatic mesh setting for floors, which was rectangular 1.25. Can refine as needed for running the analysis, but this is fine. And we have the output showing the displacement, other outputs such as shell stresses and forces, so moments, out of plane moments, out of plane shears, in plane forces can be read directly. Quickly, you can also draw a section cut. So these are direct finite element results. So we have drawn these strips. So we have the strip forces output as well. So this 4-meter wide strip covering the meshed elements, and it has integrated forces from those elements, and we are getting a single output which would be useful for the design purpose. So the forces you can directly see here. This is analysis force. The design involves wood armor, moment integration, or obtaining the design moments. So this is utilized in this strip-based design. Let us go ahead and perform the design. The design is already done, just in case, running it again, and it is displaying all the longitudinal rebars in each strip. You can see the extents in blue lines and the envelope output of this design, but from these two combinations generated automatically. And under the display, you can show rebar output. This is having the design basis set for strip based. When strips are drawn, then this output will be available. Else you can look for the finite element based and the local one direction of the slab and local two direction of the slab. Top and bottom separately, these cells will be available. We go to the strip base and you can switch to shear reinforcement. So about the shear reinforcement, this is a one-way shear check performed by the program. It performs this check at all station locations for the design strip. It's not at D away always. What user can do is can see the D away distance from this and see if one-way reinforcement is required, one-way shear reinforcement is required or not, and decide on those. Or you can also arbitrarily increase the tension rebar to take care of this shear rebar requirement, which program can also do automatically under design preferences. Increase flexural rebar for enhanced concrete shear capacity. If we say yes, it will increase the tension rebar till it satisfies no shear rebar requirement. That is also possible. We use the default cover for the slab. We can modify this for running the design. Right. The other output would be the punching shear output. We can see punching ratios are displayed as demand capacity ratios. Where I click, so we have the column punching the drop, and then one more output drop punching the slab panel. So two checks are performed. Whichever is reporting the higher, that will be reported as the demand capacity ratio. But you need to review this. But it also includes um, the automated feature to calculate the punching perimeter depth and then unbalanced moments all are involved. A particular example is available for you to review the process under the verification manual. And importantly, you can also see where I click on the corner, so the program recognizes the available punching perimeter for that. And this is exceeding, but we need to address this whether to increase the grade of concrete or thickness of the slab. All right. Now from here, you can go to the detailing. Slab mat. Basically, you'll have to go through the preferences required for this detailing. Curtailment rules, bar selection rules, typically program follows the preferred bar size. You can set 12 or 16 for this. Let's go with the 16. And you can add additional items such as bars around openings, right? Enforce minimum reinforcement, right? All of this you can enable. Let me go with this default and proceed with the concrete detailing. And it will show you this component view first, where you can review This is bottom bar. Previously it was the top one. Sectional views. The next step would be creating the drawings, which will be under drawing management. I'm using default settings to save some time. Open drawing manager. This will generate from the component views we previously reviewed. You'll find these are drawing sets. You can categorize these drawings, preliminary, tender, or construction. So under the preliminary, you can add views to the drawings. The floor slab, story one. So you can select the items you want, say top, bottom, table views, VOQ, and rebar weights. You can see this has been generated. VOQ summary. Modify a little bit here, but you can take it to the right click and export drawing sheet to the CAD program or TXF in general. Done. I can open this in a CAD program. So this inbuilt detailer could give you the preliminary drawings pretty quickly, but further actions as required can be incorporated in the generated drawings for final submission. Okay. So this is a typical use of the SAFE program in analyzing and designing the closed lab system. A few things to note here is, so program performs the analysis based on the model that you have created. It does not use the coefficient based that you see in the code, Annexure D of 456 or other codes. So it is based on a finite element analysis model. So elastic analysis results will be used and the design is performed, right? So you can perform the beam slab system as well for the elastic analysis based results, not the coefficient based. Just to extend this to cover the cracked section analysis, there are a few key things in that to note. We cover this in the same example. We go through, we unlock this model. So the recommended approach is that we need to calculate the immediate deflections and then long-term deflections. Then we also work with the sustained and non-sustained parts. I'll quickly take you through this small number of steps that you'll have to do. It's our recommended procedure. So the method or the procedure followed by the SAFE program is by Gali, Pavre, and Elbadi, book Concrete Stresses, Deformations, and it is specifically for the serviceability. So basically, so program performs an iteration using the flexural stiffness modifiers. So the important thing to note here is you should not apply any modifiers to the slabs unless special conditions required to modify the slab stiffness. So full stiffness is used, unlike in ETABS where you reduce the floor slab stiffness, welding stiffness for the superstructure analysis. Here in the slab design and the long-term deflection checks, you'll use the full stiffness. That is no modifiers. Right. So the program performs an elastic analysis, calculates the moments, and then determines the reinforcement. And the reinforcement can be utilized directly from the design result, or user can specify. Both are possible. And internally, then it calculates the cracking moment. And interpolation coefficient is calculated and to determine the curvatures between the cracked, fully cracked and uncracked states, and then computing the curvature for the applied moment, and then modifies the flexural stiffness modifiers, and the displacements are computed in iteration till the maximum displacements are not varying much, or number of iterations specified are not exceed. So typically this is a nonlinear behavior. So the nonlinear analysis will be utilized for this. So that is a background of it. Now we need to define a few cases, and then we have to combine the final result to get the final long-term deflection. So let me start with the load case, which would be for the immediate. We can call it as short-term deflection. It is called short-term, and the nonlinear static type, and the loads will be all the dead loads and live loads. So superposition is not valid because it's a nonlinear case. So all the loads should be applied in the same. So no combinations can be made for the case itself. Final results can be combined, which I will show shortly. So this is how we specify the crack short term. The default settings for the nonlinear settings should be fine for most cases. I'm leaving it to the defaults. Right. This is all loads to identify this. One can also have a load combination for the elastic analysis. We'll have, just for comparison, we don't use this, but dead load and live load and factored, just for comparison purpose. And then the input, right? So important thing to note is when you run the analysis and design, so design results are retained for the next analysis that will be used in a nonlinear load case. So make sure you're deleting if your input is user defined. So in this case, I have deleted. I'm going to use the cracking analysis option to tell the program pick up this rebar data. So the default setting is user specified rebar, which can be drawn directly into the slabs as a actual object. That is also possible, or from the design result if available, or else it will pick up this minimum tension reinforcement that we specify. Let's say if I give 0.5% for this, or you can specify a quick tension rebar as bar size and spacing. That is also possible. Let us switch back to the default. So this will be utilizing this. I can go ahead and run the analysis. So there are two options. By default, it will be run analysis and design. So if it performs the design, it again runs the analysis one more time to utilize that rebar provided in the design for your crack analysis. So if I go for run analysis, no design result is available. So it will use the minimum tension which I specified here, or any rebar drawn using draw slab rebar directly on the slabs, right? Where you're going with the 0.5%, which is specified, and I will go with run analysis. So for the long term, the live loads, permanent loads remain 100%. So live loads assumed can be 50% or 25%. It's an assumed value. Here you'll have two outputs. One is for the elastic, about 8 mm. You can see here. The other one is the short term, right? So this is about 14 mm. So another important point to remember is the crack section modulus, which is used by the program through the material properties, the M30. The program default for IS456 will limit the stress in the bar to 1 and 0.55 for short term and long term. This one can modify user specified. Say for M30 0.7 root FCK, you can give 3.83. Now you can utilize this value. Now you can perform the analyze once again. Now the reflection is 8.7. That of the combination for the elastic, about 8.6. Right. Now for the long term, we'll define load case, add new load case as long term CNS. That means it includes creep and shrinkage. Should be specified here. Let's say 25% for the long term, and floor cracking analysis will use cracked long term, which you can specify directly from the code that's provided in the code, or you can also define this time-dependent properties through the material property definition. Various user-defined and international definitions are available. You can specify directly the number of days. So program will take the coefficients from that automatically. So both options are available. Let's go with the default values here, typically used. And we have this. Now there is a sustained part and non-sustained part of the live load. So we are considering only 25% for the long-term deflection. So the non-sustained component to be isolated. For that, we will define one more case that will be short term, sustained, nonlinear. At 25% be a short term, right? So basically, the difference of this will be added to the long term. So I've defined this third case, and then finally define a load combination that will give final long-term deflection, which would be the result of long term, including creep and shrinkage, and then short term minus sustained short term. So this plus this is your final combination. Now I can go ahead and run the analysis. The deformations from individual cases. Now we are interested in the final long term. You can get up here. You can see the maximum is about 19.5 mm. I hope I have covered all the frequently used features of the program in the flow slab design. Let me try to answer a few queries. Sorry about taking a bit more time than expected. There are a few queries related to the shear wall. How to perform punching check of slab around shear walls. Yeah. So program does not perform the punching shear check around the shear walls. The reason is that shear wall will carry more than one load data, more than one joint load data. So for that, punching cannot be performed. And the other reason is in the modeling, which is related to the modeling. So the walls and line objects, if present, are connected to the joint object in it or in its vicinity. Program will not perform the punching shear check. So punching around the wall has to be performed outside the program. There is another reason because codes does not give a procedure in case of overlapping punching perimeters, right? So we have the single one for overlapping in case of walls with multiple joint loads overlapping each other, then there is no procedure available. That is, these are the reasons program does not perform it. So, there are questions related to stiffness modifiers. I think I have explained already in the presentation. Hope that would be clear. That means no stiffness modifiers need to be modified here. Okay. Regarding the rigid zone, it is a modeling technique to capture the stiffer junction of the slab and the column. Um, It is not a must, but it will give you a more realistic model when you add these stiff areas on top of the columns. So member property cannot be changed. Thickness cannot be changed after the analysis. You have to rerun the analysis with the new thickness. Yeah, at the overlapping regions, the thicker slab property will be used. The smaller area object, which is the drop, and its thickness will be used. So no need to worry about the overlap. But the slab and drop both are present. I think I have added most of the information in the presentation itself. Questions, I see all of them are repeated. Repeating the same. So if you have any specific questions, then feel free to write to us. We will answer them because that could be specific to your model. I hope the presentation was helpful. Thank you all for joining and your time. Meet you soon in another session. Bye for now.